Okay, hello everyone. Welcome to a design review. This is of our new financial framework, and we are diving into different aspects of this. Today, I think we're starting with financial series, which we had talked about previously, right? What does the green mean?
Green means it's,
Go ahead, Jason.
I was going to say fully implemented yet. It's not still under construction. The pinks means some aspects are still under construction. So financial series we did talk about last time, but you had some comments about how we should integrate it more with the financial portfolio symbol as well, and that's now there. So the improvements you asked for last time are here for the financial series head.
But when you say granularity, I mean in a date object, the granularity is day. Daily is something different, right?
Granular is supposed to frequency, you mean?
Yes, I guess so. I mean, if you're going to call it granularity, the size of the grain is a day, right? If you're going to call it frequency, you could, if you're going to say frequency, then it's daily. Just saying.
Yep.
Okay. Noted.
Okay. So now this works. Great. What's that going to do? That's going to say not available. That's a bit ugly. Why are there three of them?
They should be one. I think was fixed in a later version because we are doing three codes. It's financial data.
Okay, fine. It's just a bug. Okay.
Yeah, and all you asked for last time. It's going to
take a long time to download. It really should have a blue progress monitor.
Yeah.
So if I now say list line, well, how do I get a high-low close plot?
From the financial series, you won't necessarily have that. You want a trading chart, right? Is this high-low? This is just daily close data, though, right?
Yes, exactly. The time series version is the adjusted close price.
But financial series, I would have thought was oh, come on, what's that?
Because we didn't create the done value for list line plot of the financial series.
We know about date list plot, right?
Yes.
Yeah, but date list plot and list line plot. List line plot now works with date objects. There's no reason for this not to work.
Okay. I have to extend. I have to extend it to a certain function. The way that it's working right now is that you have to do the list line plot and create the time series of your financial.
Yeah, this should work. Yeah. This should work.
I don't understand what your. Well, I didn't understand this. What on earth would it do? What do you have to do from financial series?
If you go in the next cells, you will see the time series over there. So the financial.
Right. I get it.
Yeah, I got it. Yeah, noted. I have to extend to all the data.
No problem. All right. Okay. This is just a review of what we looked at last time, right? Before we go on to new stuff, right?
Exactly. Financial portfolio was not even defined, and so right now we are able to create a financial portfolio that has an object you can create by retrieving the financial series for Apple and Microsoft in a given day, and this will create not only the financial series of the single asset but also the weighted combination. By default, the weighted combination are equally weighted.
What's that?
This is the time series of portfolio will return the log return of the portfolio itself. So it's kind of silly to plot it. If you're doing the accumulated time series, you will get. I think this is a bug in the sense that it's not very useful to plot.
This is showing you the log daily changes. Yes,
exactly.
Yeah, but that's just the wrong thing. I mean, it should show you, if it can, the time series. The default time series should be like the value.
Yeah, it should be the actual price for sure.
Yeah, that's true. List line plot.
Okay. So what was the thing I saw which had a summary a button that said summary that came
Now,
up?
if you click now plus over there, there is a summary here.
It's exceptionally ugly in the actual appearance of that. Obviously, you can fix that, right?
Yeah, I will definitely exit. I put it over there. But the summary is what you've been asked the other day. If you click on summary, you will see that there are the summary of what we have. There is a function financial summary that actually returns a basic of the name of the asset, first date, and the last date.
Okay, but if this is a button, it really should be something that indicates that that's not the right UX. I mean, if it's going to be a thing that pulls out like that, it should have some kind of greater than thing or something.
Okay.
You can ask UX. I mean,
you have the same button for also the financial series that actually retrieves the time series, is working exactly as the time series.
okay,
we didn't
fine,
go through.
That's great, but I mean, all I'm saying is, that looks pretty random, and I wouldn't put all that stuff out there. I would just say dividend dates, and then maybe the first one and last one, and a dot.
Oopsies,
and I have no idea why it's running off the screen, and it's a mess.
Yeah. And this is the tabular view of the information that are stored inside the financial series.
That's nice, but I mean, clean this up.
Yep.
Okay. Financial series events. Yes, we talked about that, but not yet implemented.
Yeah, it has to be implemented yet.
Okay. Financial series summary, which is that summary box.
This is a summary box, exactly.
Okay. Is it useful, this financial series summary? I mean, what would you use it for programmatically?
It's not using programmatically, it's just to give you an idea when you're retrieving a bunch of portfolio information that can have different dates.
I think this would be more useful if there was some information about the weights as included here.
Yes.
Yep.
It should have the weights, and even in
now,
this case, they're all equal.
Right, but you should, I mean, the weights need an as of, right? As of the first date, probably. Because obviously the weights can organically change. Even if you start them off even, they're not going to stay even.
I mean, depends how the portfolio is built.
I understand, but right now this is trying to be just overall things to let you know what you're looking at. But because portfolio adds something extra to just time series, and weights is the main thing that it adds, it might be useful to have that in the summary box. But
yeah,
more work to have it.
I'm sorry, you're saying the weights should be in the summary box. I agree.
I'm just saying it's a little bit more complicated work for Felipe to get it there. I agree it should be there, but because the weights might not be the same. So you have first date weights, last date weights.
I see.
Yeah.
Well, I mean, why not? Why not have something? Okay, so you want to basically put I mean, you're going to have a column after each one that says weight, first date, blah, and then a thicker separator, last date, blah, and then a weight.
Yes.
Yeah.
I think a more common thing is to just show the quantity, right? And then the weight could be a thing that is like late.
The thing is, it's, I mean, you can't show the full weights, because the full weights are a complicated time series. But in a case like this, where it's going to start off with a default of like equal weights in both of them, it's only going to start that way. It's not going to end that way. And it's useful to know that a portfolio has weights as well as instruments.
But actually, I don't understand the weight. I mean, isn't it the case that the portfolio has such and such a number of shares of Apple stock?
It can have that it has a number of shares, or it can have that you determine the number of shares in order to have exactly equal weights in them, or 40% in this and 60% in that, or whatever. The usual way is as a fraction of the overall, in order to set your weights. Then you calculate how many shares you want, and you might round it or something. But that's how you set it initially. And the point is that after that, the percentage weights are going to change on you as the things move in different ways.
But if I just have some random stock holdings, and I've got some number, then I have some number of shares of this and some number of shares of that. If I'm going to change my number of shares, I've got all kinds of commissions and this and that and the other. Right? I mean, I don't understand. Why isn't it of relevance to people to just know if I have?
But most people are not tracking things by a number of individual shares they have, but by the percentages that they have in them. at least to within whatever fine grainedness they want, especially for all the analytic purposes and return calculation purposes and so forth. And they treat the number of shares they should have as being something they're just going to calculate, and then after they've calculated, they'll round it, and that's how they'll get, round hundreds of shares of this or that.
Okay.
This is the part we were talking about this, getting the two series to have the same dates and feet, and then there need to be some recalculation to do that, because if you have changes, a series with changes, you remove some of the dates, you have to recalculate the changes between the dates that are kept. So that's what this conform operation does. It puts them all on the same feet.
Right. Even though it might lose some things here, and maybe you want to check the corner case where it loses everything.
Definitely check the corner case.
What's that?
Yeah, if it's completely non-overlapping, you're right. You should check the corner cases. The normal case is that some of the days will go away, but then that means the changes for some of them will go away.
I got that case. What I'm saying is, if they're completely disjoint, what do you actually return?
I think you return missing, some kind of missing.
Are you sure? Are you sure you don't
just an empty list?
Two financial series which have no entries in them?
No. I'm not putting an empty financial series. I'm returning some kind of error message. Let me double check. I will tell you in a second.
Okay, but it's got to symbolically return something. It's not obvious to me that it's a good idea to return something with a different head.
I understand. You're saying financial series of empty lists might be the right thing, actually.
Yes, that's what I think.
Without any warning? Because
with a warning.
You can have a warning. Yeah.
Okay.
Okay. Financial series measurements.
And this is the one where you can have these, calculated percentages things, and in addition takes the second argument form of, if you have a default interest rate, it lets you calculate extra things like excess return and Sharpe ratio and so on.
Okay.
So extra down values for those sorts of things.
Good. All right. Are we on to new stuff?
Close. Yes. This is still stuff you've seen a little bit before, but the last time you want to make sure that we were in for the linear methods, that we were using the new updated model fit stuff, and now that's all there. So the factor model fits are using the new model fit stuff underneath. It was a very simple change because that stuff was modular. So you have seen some of this stuff before, but the difference is you want to make sure that we were using the newer versions of the model fit. Yeah.
But I thought model fit. I thought the way that would work is to say model fit and then factor model or something. Why is this a factor model fit?
This is probably a factor model fit for the extra things we know we want to get on top of it. But that's why it's a symbol outside. But inside, it's just calling model fit with a few arguments set.
I see. But do we have somebody from the statistics team here? Yes, we have Gosha.
Yeah.
Yes, but I'm not on the modeling. But yeah.
I've been talking to Roger and to Julio in order to have included we are using model fit down below.
I understand. I'm just asking about the design, because usually it's model fit with a certain exponential model or something. But here, so that would make me think it would be model fit with factor model or something. But you're doing something different. Why is that?
Because model fit in general, you get the data and you get the learner, the model that you want to try to fit. And here, what we are really doing is that, given a list of financial series, we are retrieving the log returns, and we are applying the linear model fit on the log returns. So the convoluted part is the fact that we are not using the price, but we are using the log returns of the price.
In other words, the data that's being retrieved here has to be massaged to the right form for the design matrix, et cetera. So there's operations before and after the model fit itself.
Exactly.
I see. But so what exactly are you returning from factor model fit? That thing you're calling factor model.
I am returning a factor model that contains several information. It contains statistical information from the model himself. So there is there are all the residual, the model fit report coming out from the model fit themselves. There are the result of the model fit that it's financial series.
How does this relate to when, normally in model fit, it will return like exponential model of blah, 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 right?
Right, and that's the fitted model thing here, which is going to, in this case, the linear model, but that's just the fitted model property. But you've got, and you can also get the model fit report for all the full information. Those are passed through, but things like idiosyncratic asset return, right, and those sorts of things are things that we're, calculating specifically.
So normally here, you do a model fit and you get back a linear model.
Yeah.
Right here, you do a factor model fit.
You get a factor model instead of a linear model.
But so how is the factor? Could I feed the factor model into model fit?
Into model fit.
Yeah, because that's what you're doing with a model here. You're saying, here's my data, here's a model, fit the parameters of that model. But this is something different, as I understand it.
Yes, there is.
So how come it looks the same? It walks and talks like a model, but it's something different.
Because I am saving the different part of the entire process, but at the end you are getting not just the model fit themselves, but also the result of how you are combining the final object. It's rather more important how you combine the model than the linear model themselves. It's good to know. It's good to know for the financial people to understand what are the weights, the estimated parameters. But they're not going to use that, and you have directly the resulted model.
Okay.
So
hold on. The main problem is star model has a definite meaning. Linear model, exponential model, decision tree model, whatever it is, right? That has a definite kind of meaning. There's a definite thing you can do with it. You feed it into model fit, and it fits data. Okay. If you have a thing called factor model, it better do the same kind of thing that linear model and exponential model and so on do. But you're saying it doesn't do the same thing. I can't use it in the same way, so it shouldn't have a name that is of the form star model.
Okay, you're right. You're right. At this point, the name is misleading.
Okay, so let's go through what it should be. What is that thing?
I mean, it's a financial factor model specifically, because when you say financial factor or factors in factor model in the finance world means, right, the risk weightings on the different components of the return. In this case, market and alpha and beta.
Okay, but fine, but it's not okay. It's called a model sometimes in English, right?
Yes.
But in our way of naming things, it is not a star model type thing.
I understand.
Right. So the question is, and
so I'm saying something where if we say that it's a financial version of this, will that help?
No, it will not help.
Okay.
If it ends with model, it's not going to help.
We have to delete the word model. It's financial factor. Financial factor.
It still has a bunch of the same properties, though. Of any, it has best fit parameters. It has a model fit report, right?
But you can ask for the fitted model where you are going to have some linear model that is usable in mathematics, and so these things should be like
if you extract. The point is, it's not clear to me it's completely different because you can still extract those things and use them as you would use other.
Yes, I understand.
Model objects. It's more that there's added things on top. I agree that it's a complication. Yeah.
Right. And what? Wait a minute. Where do I see the
if you scroll down slightly, the measurements grid and so that if you scroll down slightly farther, we can see the index legend. Right there you go. So I mean, you have the stock here in blue, what the market did that it's being regressed against, and then the factor model in green of how good or bad the fit is, right? And you also can see, what's the portion of, in this case, the beta parameter, the 0.57 is, the portion of the return of Apple that just looks like it's taking market risk, meaning it's zigging and zagging at the same times, et cetera.
Yes.
Which is what people want when they think about if they are an Apple, how much market risk are they taking?
Okay,
go ahead.
No, I'm still completely confused. In this okay. It's not a model in the okay, but what is it? It's not in the sense that we're using the term model, which is a fit to data. This is something different.
This is also a fit to data, right? It's saying how much of the return of Apple can you explain as just being some leveraged version of the return of the market? And the answer is only a certain R squared, right? With a coefficient of the how much they move together, a correlation effectively of like the 0.57 parameter, right?
Yeah.
So only some of the variation, you can get the R squared down below, only some of the variation in Apple is explained by it just being a leveraged version of the or under leveraged version of the market. And the rest is its idiosyncratic return. But that's the single factor case. The more complicated cases, when you have other style factors, whatever you can regress against, you can say that this is taking large cap risk, or this is taking growth risk. And those are the kinds of things that the market participants want to do, is they want to understand for all the different stocks they put in, how much of these different style risks they're taking in the different effectively semi-independent characteristics of market return. And this is used for return attribution. My return was this good, but it's only because I took more risks than et cetera, right?
Okay. Look, okay. So my complaint here is,
look, I want to step back. I understand your complaint, but I want to step back for a second. The purpose of doing things where we're adding on functions specific to the vertical application to finance is precisely that the things which are mathematically clean and true of the model fit underneath are not quite everything that they want to need. Otherwise, they just write the code themselves, right? We're trying to do the things that are special for them. So yes, there's a design issue of how to get that fit nicely in the language, but we're always thinking about the specific application that they're using.
Right. Okay.
And in defense of the name, which probably financial factor model fit, we have time series model fit and time series model, which is different. I mean, it fits to the data, but it's not in the linear model family of
time series model fit is going to give you some autoregressive moving average model of the thing.
And
is
it
it
has
a
its
fit
own
or is it a find? Should it be find factor model? Is it which is a better terminology? Model factor model fit or find factor model?
I mean, I think it's fit because it's to data.
Okay. And your point, Gosha, is that time series, what is the function?
Time series model fit, yeah.
Time series model fit and time series model is the object resulting from that. It's kind of a precedence that we have a special model.
Yes. The other one we do use in other contexts, though, is things like find process parameters, where it's it's just giving you the parameterization of a process of a certain type. But that's not what's going on here, because the process is just a linear model. So,
okay, so your argument is time series model fit, which is an older function that predates model fit.
Yes. So let me explain. So in a way, you could do a lot with having estimated process, which is find process parameters, because you were estimating the parameters for for some process. But time series model fit does more, because it does the automatic heuristics to find the family of what time series process. So in this first example, you see that it finds the ARMA process, but you just gave it data, so it can run some hypothesis tests under the hood and then choose which which family of the processes was gonna go and look for the parameters and orders to find that. And then it also has its own diagnostics, because it's gonna tell you which were the candidates and what are the value of the criteria that were that were computed to choose the best model. So I think this is very much related to what we have here in the factor model, because it does special things, and then it also has a different kind of properties that are specific for this modeling here, for this data.
All right. Well, okay.
I agree with the precedent. Yep.
Provisionally, I guess it's okay.
The only suggestion I would have maybe to have the financial in front of it,
There's just factor model. Yep.
Yeah, so financial factor model fit, because factor, you know, I feel it's very generic.
Yes.
Yeah.
Fine.
Yeah, that's
Financial.
that's a friendly amendment, I think.
Okay.
Okay.
Let's move on. Okay. So financial factor model fit and financial factor model.
Yep.
Okay.
Right. So, and the next example is, one of the things academics care about is, are some of these models better than others? The previous one with just the alpha and beta is a very, in this particular stock, very low R squared. Didn't explain much of the variation in Apple. But if you go to a 3-factor model where you can have large versus small and growth versus value styles as well as the market, you can get a significantly better fit. And there's lots of sort of mutual fund math that's based upon this kind of analysis of trying to find the right style factors that actually characterize.
Okay, but what on earth is financial series pair log return difference?
Sorry, where?
Yeah, the financial series pair log return, it's horrible name. I agree. And but the reason is it's very special case to create a financial series that represent the large versus growth.
I got it. Yeah,
right.
You're right that it's a Baroque name. What are we doing here? We're creating a new financial series out of the difference between two financial series. So we're not putting in the large cap and the small cap. We're doing the large cap minus the small cap. So we're making a synthetic series out of two series by just and only in the dimension of their log returns, right? So we're making a new log return series of how much the large caps outperform the small caps, or how much the growth stocks outperform the value stocks. Does that make sense?
I thought financial series was values of some financial instrument, not differences between values of financial instruments.
It's an object with lots of things in it, including the actual things, the log differences, dividends. It has lots of extra properties in it.
Through time, but this is taking, this is taking an index minus whatever it is. There's probably two.
Yes.
Indices, but
yes.
But normally, financial series is not a, it's a thing that represents the sequence of values of an instrument, not this difference thing. Well, I'm confused. But why can't you just get the financial? If I just take two financial series and I put a minus sign between them,
you're not dealing with them in the return domain. So the fact that one of them has 20 times the price of the other one will, just make them completely incomparable. You first have to turn them into returns to make them comparable.
Okay, well, how do I go from financial series to return financial series?
If you only have the original series, you're basically doing the log of the differences of the list.
I know, I understand, but how do I get that in our system? Is it a property of financial?
It's a property.
Series?
It's a property of financial series. It's already calculated for you, so you just ask for that property.
If you click on the plus button and you will see the view, you will see that there is a column called the log financial.
Okay,
log.
fine, but then what you're saying is, in certain cases, you want to turn financial series into a financial series not of
the values, but of their
log
differences.
Yeah. Right. This is super confusing. This is a log differences financial series, as opposed to a value financial series. Are those the main kinds that you want?
Yes, those are the main kinds you want.
So maybe we should have something called, difference financial series or something like that.
Well, let's be clear. There's two different versions of differences here. There's just differencing the list itself, which is, and then there's this one, what we're doing here, which is comparing two of those.
Comparative financial series, something, a different head for this thing. Is that crazy?
I mean, you don't want. I don't think you want financials. I think you still want financial series to be able to work as a head for this.
Does it have the right properties? I mean, this is a thing of log differences between. You're
not wrong. I mean, what you could do, we could make it completely comparable to financial series if we just did accumulate across it and made that as our index number, right? Version of the level as opposed to the log changes, and then it would be completely comparable. Because for anything where you have log differences, if you just do accumulate of that and then exponentiate it, you get the resulting quote price series. What would be a price series from those log differences?
Yes, but I mean, so
You just don't have a basis for other than like an index number. You start at 100 or something like that. That's the typical way it's done, or start at 1.
But I'm trying to understand. Is there a financial series changes or something head that's useful, or is it the case that you exponentiate it up and you turn it into actual value things and always store it as a financial series? Because I just don't think financial series. I think when you have financial series, like when you put it in financial portfolio, you're going to get it all messed up if you put it into financial portfolio, something which is one of these differences things.
I think you're right that we should keep, but I think what you should do is just always have both of them. You should always have the level, and you should always have the differences, because
That's
you're going to
fine.
use them for different purposes. But one's basically just the differential of the other in a finite sense.
So then the only question is, how do you take two financial series and combine them to get a single financial series? And you could,
Right.
Why aren't you doing that with a minus or a plus or something?
As long as you know that you're doing that minus or the plus in the log differences domain or in the returns domain, yes, you can.
Well, would you want it in the other domain as well?
Only as the result of having done it in the log differences domain and then turned it back into a price series. You wouldn't want it otherwise.
Okay, so fine. So then we could get arithmetic on financial series to work in the log difference domain.
Yes, as long as we just document that's what it's doing. Yes.
Right. So then this would become just this thing here.
I should put in a proviso. I mean, so all this is always the right thing to do for anything we are talking about. Positions, series that are things which are investable, things with positions. There are cases where you want to do something different from just doing everything in the returns domain before you combine them. If you're talking about something like an interest rate series and trying to forecast an interest rate series, you would have to do something different, because there it's arithmetic, not geometrically put together.
Well, maybe we want something like this: financial series combine. Financial series. Do you want sums or differences? Typically, you want differences, right?
You don't know what differences.
Yeah.
But I mean, again, differences. Yeah, I mean, in principle, you can combine them with any weight, right? They're just like a portfolio, right? You could, the difference is the case of plus this and minus one of that, right? But you could have a different way of combining them. But the general thing of having any weights on them is portfolio, not its own bespoke thing.
But could you have a portfolio with negative weights and is it equivalent to the subject?
Yeah.
Yes, you probably could.
And is it equivalent to the subject?
Yes, it would be, for at least its total return thing. Yes.
Okay.
So maybe the clean way of implementing this, instead of these very long names, is to just make this a portfolio of plus large blend minus 100% large blend minus 100% small blend.
One would think. And so when the portfolio, that's done with an association, is that right? How do you give the weights in the portfolio? No, you do this.
There is.
Yes, it's weights in front. Yeah,
that's pretty nice. I mean, 1 minus 1 arrow, blah 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 blah. It seems pretty nice to me.
I agree. That's cleaner.
Okay.
That's a very good suggestion. It's cleaner.
Okay, financial portfolio it is.
Okay. All right, and then everything else just follows, because you're just getting a financial series, and then you can do all these operations on it.
Yeah.
Or, I'm sorry, you're getting a financial portfolio, and then you can do these operations.
I'm not sure. I don't remember if this is a financial series or financial portfolio. Right now, I think I need to investigate, but it definitely should be the financial portfolio.
Okay, fine.
Yes.
Did we discuss this last time, this tracking portfolio
thing? I think we did. Well, right now it's taking into account the financial portfolio. So right now you have financial portfolio. This is a list of stocks, and then you are creating a portfolio. So right now,
this is finding weighting. This one here
is this is equal weighting, exactly, and then you are getting in the next function. You will see it's down below, that is find tracking portfolios. Yes, you're trying to mimic a particular, for example, index. So
yeah, so find the weighted combination of the instruments that gets closest to the index.
Yes.
So if you put these percentages in these weights in these different stocks, you'll get as close as possible to the index using those instruments.
So I'm a little bit confused by this. Here we've got the names. Here you've got the tickers.
Yes.
You've got name arrow ticker, and here you've got name arrow weight. I don't understand that.
The name arrow ticker is just to assign them so that you can have a way of referring to them by name for have nice labeling and so forth. But
but how do you combine if you want to do both in one step? Both give the ticker and give the weighting. How do you do that?
If you just gave ticker and weight, would it work?
Yes, exactly.
Put ticker and weight in a list or what?
Yeah, ticker weights in a no, for the financial portfolio, you have a list of weights goes to the list of tickers. Now, what we are going to do is that given a list of ticker, we are using the financial data to retrieve the name. So Apple is, you go to Amazon will be Amazon, exactly like this. So right now it's kind of redundant what I've done because we are using financial data. But for a particular index, in particular this index like VTV, you will see there, the real name is like SPX 500 coming from Vanguard and stuff like that. So it's easier to track it as large value for better comprehension, but it's completely optional. And the fact that we're using the name and not the ticker itself is because it's easier to read through the entire visualizations.
Okay, but fine. But I'm just saying, I don't understand. We're giving here, it's an association which has the pretty name, arrow the ticker, but equal weight. So let's say I wanted to weight American Express here twice as much as the others. Am I doing this?
No, you should have you should have the list of weights goes to this association.
Okay, so but that's not consistent with what's happening here.
Well, that's because here we're using a function which is specifically solving for the weights. You're saying that you should be able to do an input where you're giving the portfolio that way.
Ah, okay.
We do that in a bunch of, bunch of functions around machine learning and so on, I think have multiple input methods that include
weight list goes to name list or those paired instead, you're saying?
Well, I'm not sure if it should be paired. I'm kind of thinking
scroll down to what we had as the output, because I think that was the one that looked clean. Yeah, so name right arrow weight.
Yes, but the problem is what happens
cleaner.
if you want to give the ticker?
That should work too.
What about if you want to give the name and the ticker?
No, you should, as an input of financial option, you definitely need the ticker, not just the name, because otherwise I cannot look for.
Okay,
but
Amazon. You need, but financial portfolio, you need the ticker and the weight.
Yeah.
Right. So how are you going to do that?
So weighted portfolio should not return the names, is what you're saying. It should return the tickers because that way it's reusable.
Yeah. Okay. And I can add this down value as this output as an input for the financial portfolio. Yes. I can,
no, hold on a second. So the default form would be just
so there are tickers and weights. I think tickers and weights would be the default form because that way it's has all the information, whereas names on their own don't. Names on their own are kind of like a display form or like a form.
So how do we get the names input? How do we give the names?
So the names are so if you do the dollar sign question mark financial portfolio, you will see the documentation. Right, it's raw because the building backup building have some problem this week. So click financial portfolio, evaluate, and click on the eye icon on the right. You will arrive at the documentation. And the documentation, there are various over here. We wrote various examples of how these things are is being called. So there is the financial portfolio. The first one is the easiest one. We are doing equity weight on the ticker. Just on the ticker, and if you're going to under scope, you will see that there are several other down value that you can call. These things are using the name goes to ticker or portfolio goes to the association. Name goes to ticker and stuff like that. Or you can use even to the financial series itself.
Okay, but I think there's a case that's a little weird here, right? Because you've got weight arrow and then an association with name arrow ticker, right? But what you're saying that you want to be able to do is just say ticker arrow weight.
We can.
Ticker arrow weight should work. Yes.
A new down value.
Name alone arrow weight would not, because it's not sufficient information. But
Exactly.
Yes.
yeah.
But I don't understand how you enter if at the very beginning. Okay, so you're saying if you want to enter weights and names, you should use this form, but it's pretty weird to use this form then. But if you were to use tickers, you could just use ticker arrow, whatever.
The time to not use ticker arrow whatever is that if you need to substitute for the default name, right, for display purposes, like the Vanguard Value Index Fund is like too clumsy name to use as opposed to large value.
Yeah, I mean, there's another problem here, which is that you're using keys, association keys for these names, but the fact is you might not want them to be unique. You know, you might want
the way
3
association keys are
Vanguard
supposed to be.
Yeah, they have to be unique. The keys have to be unique, or it just
Yes.
drops the elements. So I think having the display name on the left-hand side of the association is a lose.
Okay,
I kind of think that the right thing to do is what you guys are saying, which is
tickers on the left, and then if you have display name, it's a right-hand payload in the association, never a key.
Or it's a completely separate association that just gives display names. Because you can default some display names, right? The display name, you know, can come from the entity system and so on. So maybe I think there may be a mechanism for this in some of the machine learning functions, and you should look. But my initial suggestion would be that it's either wait list arrow list of tickers, or it's association ticker arrow weight. And that the display name goes in a completely separate argument or option.
Okay.
Yeah, I'm convinced you're right that we do not want display names as keys on left-hand sides because they're insufficient for actually specifying the instrument.
Yeah.
Okay.
Okay. No, good input. So just the things you can get out of this, you can see the tracking obviously, and there's separate things for tracking errors and cross correlations of the instruments and so on as properties.
That looks lovely.
All right, and this is, I think, the closest we got last time, the fine efficient frontier. This is a typical minimum variance portfolio kind of calculation that people want to use linear methods for. The extra thing you talked about last time was wanting this to potentially return objects that can be interpolated, and I think we did that.
Yeah.
So if you have an efficient frontier now, you can also we return these efficient frontier points, which are the things which are calculated, for the minimum variance portfolio along all these parametric points along the frontier. But you can also interpolate between them. So if you just give I think in this case an expected return, it will tell you the weights that correspond to that target.
If you scroll down, you will see the down value of this thing. So there is a function that computes for a given return. It computes the financial portfolio that minimize the risk.
So this is, and to be clear, there's some cases where this is, this is always going to work when your weights are constrained to be positive. When you allow shorts, it just gets a little bit harder to do the interpolation. But you can interpolate all the points along the frontier, so don't just get the few points, which is what we had last time, but the interpolation now as well. So if you ask for one of the ones which isn't one of the points along the frontier, it will still find the weights.
I see.
Now the complication there is if you are allowed to do short positions, then it's not always guaranteed that this is going to be easy to find one.
You mean by interpolation? You have to
Correct.
might have to recompute the whole thing.
You might have to recompute for that case. You might have to do n minimize again.
Well, but
yeah,
I mean, and you're doing that, right? It's
yes.
Like some things are efficient and other things are slower.
Yeah.
Yes. If there's negative weights allowed, it has to redo the n minimize instead of interpolating between the previous solutions.
Okay. I should run along in a moment here.
Okay,
So I
the
think
part we
we're-
haven't got to yet is all the stuff about Monte Carlo simulation methods. The main idea here is just to, you want to be able to approximate the process based upon a marginal distribution and basically do random walks with the past marginal distribution, and then be able to do forward simulations using that method and get quantiles of the path. And then the main application for this is to do options valuation, where you get to use an empirical shape of the returns instead of a log normal one. So there's a bunch of stuff there for the simulated option values, and the Greeks, we're still working a little bit on the Greeks, that is the derivatives of the values with respect to all the different parameters. We have all those things for the theoretical values in financial derivative, but now we can do them by simulation instead, which means that when you're doing a simulation, you don't have to, none of the idealizations of the Black-Scholes need to be in there. You can just use the actual empirical marginal distribution. So there's a bunch of extra features for that, for relaxing the assumptions of believing in the past. Basically, when you do the simulation method, you are going to believe in the past trend as well as the past shape of the marginal distribution, but you can relax that and say, oh, I want to get the marginal distribution, but I don't believe the past trend, center the trend at 0, or center the trend at the no arbitrage condition, it's called, which is basically the price will change based upon the risk-free interest rate, not the past. So this is all about how much you want to believe the past trend when you're doing the simulations.
All right.
Okay. But there's a bunch of stuff like this, which we're not going to get to all through all this today, but so that's just
I have two comments. One is, how does this dovetail with the random process stuff?
Yep. It's more discrete at the moment, but it there are places,
Ito processes and things like that, right?
Yes. So there's a definite application here, because you can choose that you want to have this simulation stuff for the fitting thing, use a mean reverting walk that is an Ornstein-Uhlenbeck process instead of just a pure random walk. And there's options in here for that. So not necessarily everything you can do with random processes, but definitely the Ornstein-Uhlenbeck processes, as opposed to just the meaner process, which is basically what's going on when you're doing the basic random walk. But you can force it to be mean reverting, is what I'm trying to say.
Right. We need to cover this next time. But
okay.
I'm going to comment that this is grotesque.
Yes.
Yes, it shouldn't be there.
I mean, you either call exercise percentage, or you have it be,
I agree. Not a percent number. Yeah. Agreed. Yeah. Let's just try to tell you the number of times that the call was exercised, but I get it. Yep. It's not the right way of showing it.
Right. Okay. This stuff is developing very nicely.
Okay, great.
All right. I look forward. I think we have another meeting later this week, right?
No, that one later this week was moved. It's the next one is next Wednesday.
Yeah.
Okay.
And next Wednesday, we're going to cover this stuff about interest rate swap contracts and mortgage-backed securities.
Okay, that's exciting. I look forward to it. I'm going to learn something.
Okay.
I'm going to go off and do a philosophy live stream.
Very nice.
Okay. All right. See you guys soon.
Okay.
All right. Take care.
Okay. Bye.
Thank you.